Well, welcome everybody. This is Energy Harvesting and LoRaWAN, the IoT Holy Grail, question mark. I'd like to see my panelists just introduce themselves briefly. I'm Robin Duke-Woolley, by the way, CEO of Beecham Research. We operate in the IoT market, have done for the last 20 years. So we understand the market. But I'm here to learn a bit more about energy harvesting, actually, from these experts. So if you'd like to introduce yourself briefly.
Thanks, Robin. So I'm Jerome with Dracula Technology. I'm co-founder and VP Sales.
Great.
And we do energy harvesting, light energy harvesting.
Great.
Hi, I'm Pierre GELPI. I'm in charge of sales for EPs in Europe. Our mission at EPs is really to remove the batteries from the devices. I've been spending almost 8 years in the past in the LoRa business development space. I know this ecosystem, and I think it's a good mission now to really remove the batteries. We are doing this for two main reasons. One is, of course, the environment. We are reducing the toxic waste. We are reducing the carbon footprint also for remote controls. It's like almost 40% reduction of carbon footprint. And the second reason is, of course, maintenance, because you don't have to change the batteries anymore. So I think it's a great mission, and the message is all the devices that see some light, either indoor with my friend here or outdoor with my other friend here, they can be basically made autonomous. You can remove the batteries.
Hi, my name is Jeff Crystal. I'm one of the owners of VOLTAIC Systems. We make solar panels and solar power systems for outdoor devices, primarily IoT devices.
That's great. Okay, good. Well, I did want to actually start by asking, why do we need energy harvesting? So you kind of started to answer that, but perhaps give the others an opportunity to answer that as well. I mean, at the moment, we've got a lot of stuff out there, even the low power stuff, where they have up to 10 years battery life. But it's then a question of, well, sooner or later, you're going to change those batteries. So I don't know how you see it. Do you see that as a big issue coming up? Or
That's a big issue. As it was mentioned by Pierre, energy harvesting is a real key for mass deployment for IoTs. Because right now, everything is battery powered. Before it was on-grid. We moved the on-grid by batteries, but batteries is another wire. You still have to change it, as you mentioned.
Yeah.
So that's why it's really important to consider other option. And in the case of Dracula, we are mostly working for indoor use, mass deployment. We speak about thousands and thousands of sensors and IoTs that are spread around a building, spread about some plants. And the fact that we are able to generate energy by its own, just keeping the product there, as Pierre also said, when you have light, it's good enough. We generate energy by its own. So it's already an existing energy, we just recycle it. So despite this, you also have, of course, all the end of life of the product, if it's a battery powered with lithium and so on, which is tricky. In our case with Dracula, everything doing is made by inkjet printing, and it's fully organic. No rare earths, no heavy metals. It's fully recyclable. We can size it properly, not to oversize it. So yes, for mass deployment, energy harvesting is now getting a real answer. And something important so is TCO, overall cost, because not only the product itself, we speak about the data transmission. And IoT is there to collect data, to transmit it. If you have no more battery, you have no more data. The fact you have to change the battery could create you some issues in the meantime.
right. Yeah, yeah.
Yes, I think if you're transmitting a couple times a day, and you can run for 10 years, I think that's certainly possible. I think what people are coming to us for is they're sending data maybe every 10, 15 minutes, they have higher data transmission rates, or their sensors are using more power. And so the primary battery would just have to be so big that it just doesn't become feasible. So what we're seeing a lot is, you have customers that are deploying in remote locations. So it could be in the middle of a forest, on top of a mountain, in the middle of an agricultural field. And if you had to replace those batteries, maybe even if it was every 10 years, but every 5 years or 4 years, it becomes a huge maintenance cost. It also becomes a waste of carbon. So what we want to do is we want to reduce that maintenance load, and we want to also reduce the size of the product, because if you have a solar panel on the product, you can have a smaller battery, and it's a smaller footprint of the device.
So form factor is a bit of an issue, isn't it? I mean, are you looking to have a very small form factor for energy harvesting to replace small batteries, or how does that work?
I mean, there's always trade-offs, but ideally, if you can shrink, and a lot of it comes down to energy consumption, so the more that you can reduce the energy consumption of your device, that means that you can have a smaller solar panel, you can have a smaller storage element, you can have less plastic, and so all those things feed into the BOM, and our goal is that customers have a economically viable product, and so that the lower all those BOM costs are, plastic, energy harvesting platform, as well as storage device, that means it's a more viable product long term. So yeah, it's form factor, but feeds into cost.
Yeah, and what about the total cost of ownership? Is that?
So total cost of ownership is something very important, because we consider always the cost of the battery compared to a complete solution with a supercapacitor, with a PMIC, with a harvester, in our case, photovoltaic solution. But bottom line, when you have to use that, again, it's as everything that was just expressed by Jeff. You have all the reduction. So of course, total cost of ownership is the initial cost, plus all the daily, monthly, or whatever yearly maintenance you have to do, the recyclability at the end of the product. So, and we have something very important, TCO, we made a calculation. If you deploy this on a 10 years lifespan, we're about 30 to 35% reduction in the total cost of ownership. And also the fact that you're using energy harvesting, in some time you're able to use it more often than a standard batteries, because as you mentioned, 10 years, yes, in certain amount of transmission a day. Energy harvesting, if we use the light, anytime you have light, you're able to generate energy and to store it properly. So that could extend the lifespan of the product itself by doing this.
So would you like to add to that?
Yes, I mean, the best example, I think, is smart building, when you have devices, battery-powered devices, and you have some SLAs or commitments to replace those batteries, and you have to send someone to replace the battery. The cost is huge, right? So just install and forget is a great saving in terms of TCO, and we see that in other spaces as well, right?
Yeah. So when you consider the total cost of ownership, you're taking into account the cost of replacing batteries as part of that. When you're comparing energy harvesting, where you don't replace the batteries,
yes,
with a battery alternative, where you obviously are replacing batteries after a long period of time, you're equating those together for the total cost of ownership. The benefit is with energy harvesting, because you haven't got to go out to every unit and change them around. Is that right?
Yeah, I think there is no discussion. I mean, it's obvious when you have to send someone to replace the battery, then you lose you lose that. And it's, I mean, the cost topic is even true when we talk about AAA batteries that cost almost nothing. We see that with the remote controls. It's not LoRaWAN, but Samsung has a solar remote control, or light-powered remote control. They are selling millions of this, and they are accepting the few additional dollars to the BOM, because it's a huge user benefit, and again, environment benefit as well. So even if there's a small additional cost, it's now acceptable. So,
okay.
Yeah.
So what sort of applications are you finding? You talked about forests and stuff like that, but is that the main area, or would you say there are lots of others?
So we'll sell about 1 million panels this year for IoT energy harvesting applications.
Okay.
Within LoRaWAN, I think the biggest category, so in New York City, we're powering a flood monitoring program called VERNET, which sits around at key points throughout the city and looks at water levels. So that's one of them. But then agricultural for us is probably the biggest. So there's a company called, two companies in Italy, NetSense and Irio, that are measuring agricultural variables and driving things like irrigation. as well as several in the United States. There's one called a grail Eco, and there's another one called Agrology. So in the outdoor world, I'd say agricultural is probably the biggest one for us.
Okay, all right. Is that the same for you?
No, because we do photovoltaic, but for indoor use.
Okay.
So that's where voltaic is much more efficient for outdoor application. Our core business is mostly for indoor use, ambient light like this. We have enough light to generate energy and power. So that's why the main applications are related to smart buildings, mostly to manage all the environment in a building, temperature, humidity, presence detector, fires detectors. So all this, it's important. And now the booming we see for the past few months is around asset tracking.
Right. Asset tracking.
Asset tracking,
Oh.
yes. For example, we have here a label that will be presented tomorrow with the workshop. This is an asset tracker, autonomous, that can be reusable. So you can place on any product and you'll be able to track with LoRaWAN in that case, particularly. So this is a very heavy trend for tracking products, tracking people everywhere. And that's one of the main new business that we see.
So that's a label type thing, is
That's
it?
a smart label tag, correct. Everything
Okay.
inside. You have the tracker, you have the power, you have the storage, supercapacitor printed, everything is this.
Right, and that goes on the outside, does it, for the energy harvesting?
The energy just being there, we have here the photovoltaic module, and we
Right.
generate the energy with this, and after we store it in a supercapacitor made by inkjet printing.
Oh wow. Okay. Yeah, that's fantastic. What applications are you finding?
Yeah, I mean, I spoke about the remote control. I think for us, it's millions or multiple millions of units for remote controls.
Right.
But in the LoRa space, I would agree with trackers and agriculture. And the example is this cattle ear tag that is solar powered. It's rolled out in 23 countries, and yeah, it's a good example of tracker that has GPS, Bluetooth, and LoRaWAN, right? So that's an example.
And to add to that, there's a number of applications around virtual fencing. So instead of using lots of electrical fence, you can actually use the tracker with stimulation to guide livestock into a given area, and that's going to be, I think, quite
Right.
large as well.
Yeah. So for positioning, using what GPS? You're saying you're using
In this example, yes, it uses GPS because it's outdoors, but obviously indoors we have other examples of BLE tags for indoor. So you have different technologies for geolocation, but we have light-powered trackers both for indoor and outdoor.
But location tracking, that takes quite a lot of power, doesn't it, to do that?
Well, it depends the number of messages you
okay. Right.
send per
Yeah.
day, of course.
Right.
And on that point, I would say that it works. I mean, we have examples.
Yeah.
Don't be afraid about geolocation. To start a project, you just have to come to me with the power consumption of your device and the size of your device. And in a few minutes, I can tell you how much light and what exposure time
You'll
it
need.
needs to be made autonomous.
Right.
And if we cannot make it autonomous, at least we can extend the battery life for sure. So
Well, that's okay if you've got a fixed location for the device, so that you can measure the ambient light and stuff like that. But what if it's moving? How do you do that? Because if you're doing asset tracking, it's typically on a moving object. You don't know what the ambient light conditions are going to be from 1 minute to the next. So how does that work?
so for
Well, perhaps you could.
sorry.
Yeah,
No,
give
no
a
problem.
chance.
For me, no, it's exactly. We speak about the perfect triangle for energy harvesting. We have
Right.
to consider harvester, could be photovoltaic, any other. We have a PMIC that will guarantee the collection that will be done properly, just
Right.
to avoid any leaks. And you have the supercapacitor storage element. So any kind of energy harvesting device, you need a storage element
Okay.
to make sure that it allows you to work without any light.
Right.
You cannot imagine to get a sensor or a fire sensor not working during the night.
Yes.
So that's why we have a supercapacitor, we have a battery, we have different options that allow us with the PMIC to make sure that we are collecting enough energy. That's why when Pierre mentioned about the power budget, once we know this, we know exactly how long we can last.
Right.
We have some demos that are working now that can last 2 to 3 months in the dark.
Oh wow.
Being able to ping once an hour, once a week, depending exactly about the power profile.
Okay, yeah. So it's a regular pulse, about once an hour, up to once an hour?
It could be for, we have on a boost, if you can stop on a boost, you will see we have a transmission once every second.
But that's going to use more power, presumably.
More power for sure, but it's always related. Compared to a battery, consider it's a full tank of energy, and you relieve and you pre-live a little bit. When there's nothing, there's nothing.
Yeah.
If you consider energy harvesting, it's kind of a bath tube, only with some drop of water coming daily.
Yeah.
So that means it will never get empty. So you still have some light. So you wait a little bit, you get a signal.
Right.
That's what the benefit of energy harvesting. You'll never be short of energy from zero. You still have something happening. So that's why it's a main importance. When the battery is empty, that's over.
Right. Does yours operate the same way?
Yeah, I mean, as Jerome said, if the device is properly designed, you can stay several weeks or several months without light, right? The remote control can stay 2 months without light,
right?
Because for energy harvesting, as Jerome said, you need, in addition to the application, you need 3 blocks. You need the source, so photovoltaic cells in our case. You need a storage element to store some energy, so it can be a supercap, it can be a small battery, or it can be a hybrid caps.
Right.
And you need power management, and that's what we are doing at EPs. We are doing the electronics. We have a chip actually that optimizes really the end-to-end system to avoid losing the energy that you have collected, and protect the storage element from overcharge or over discharge, and fuel the application with a proper voltage, right?
Okay.
And if you don't have that, then you either lose the energy you have collected or you kill your storage element. It's a little bit like a car. If you have a big engine and small wheels without transmission, you kill the wheels. And the opposite is true as well. If you have a small engine and big wheels and no transmission, the car just doesn't move, right? So you need an end-to-end system, and this is what power management is doing, and we are doing at EPs.
Fantastic. And do you operate? Do you do asset tracking as well?
Asset tracking is probably one of our largest categories.
Oh, it is.
Yeah.
Okay.
So I think there's often going to be a tracker on a shipping container, and the shipping container might be at the bottom of the vessel for 2 months.
Yeah, that's what I was thinking.
And then it comes out, it charges up, and then but again, the storage element is what keeps it running that whole time. Right. There's the basic equation is, on average, you need to be producing more energy than you consume.
Right.
And so there's all sorts of tools out there that can tell us probably in a grocery store, how much light's available. But for us, how much sun's available in Amsterdam in December, and we can, but we can tell you that. We can tell you that, not a lot, but there is some. And so we can tell you how much available, and then we can build a model that says, here's how much energy is available for you to use. We know what your power consumption is. Here's how big of a panel that you can make. And then it becomes really down to the engineer on the back end to be designing the system smartly so that when there's low power, maybe they send data less frequently to keep the system alive 100%. But our goal is really, we're making products to be durable enough. So there's that basic equation, but then you need to make things durable enough. So after 10 years on the ocean, everything's running perfectly. And that's, I think that's the trick.
So what is the life of the product then? I mean, so you're not depending on a battery which lasts for a finite period of time. One can argue how long it is. But with energy harvesting, what you're providing, does it have unlimited life, or is it?
It's definitely not unlimited. A standard glass solar panel with a frame, which we're not making as many of, is easily 25 plus years.
Really?
The small panels that we're making, we're testing and qualifying them for 10 years in Florida sun. So that means high UV environments, rain, everything else. But then so we're expecting typically longer than that on those devices.
Right. And what about you?
We guarantee for indoor use, we guarantee 8 to 10 years lifespan.
8 to 10 years.
Yes, with about 80% of the initial performances. Saying that it will never stop. It will maybe decline and generate a little bit less energy, but it will still be active.
Yeah. So it could actually last for a great deal longer than that.
Yes, of course. It will not be when you reach a certain amount. No, as soon as you have a light, it will be able to generate. And if it lasts, of course, it will decline because it's organic products. So you have an oxidation, but the oxidation is really limited and measured. That means after, when I tell you 8-10 years with 80% efficiency, meaning that maybe adding 2-3 more years could still be 70% efficiency. So
okay, so it just gradually goes down.
That's it.
So
that's organic.
Over a period of time, does that mean that you stop receiving signals, or you...
It could be maybe some delay. Instead of receiving maybe
Right.
20 or 30, you could reduce a little bit.
Okay.
So that's basically
So that's how
what
you
happens.
would, that's how you would notice the difference, that it's
That's
taking
it.
longer for the signals to
that's
get
cor-
back,
that's
or
it.
longer between messages, or something like that.
That could
Okay,
be. That's the way you detect it.
Yeah. Now, I also wanted to ask you about this indoor. What energy do you use indoor? I mean, is it like floodlights or?
Any kind of light. That means
Any kind of light,
A
okay.
photon is a photon. You can see on the booth we have a demo working with surrounding light. That means it's about, here the light is about 300 to 400 lux. It's
Right.
nothing compared to, when you speak about solar, we speak about 100,000 lux.
Right.
But as low as a few hundred lux, we're able to generate energy.
Okay.
Not a huge amount, but still. As soon as you have light available, that light will be stored in a supercapacitor in a battery just to be used later on.
So it doesn't matter what kind of light it is.
Doesn't matter at all, because we use only the visible spectrum, so that's working.
So it doesn't need to be sort of ultraviolet or something like that.
No.
It's anything that's visible.
Anything visible.
What about infrared? I mean, is that?
No, it's
No.
not working for infrared. It
Okay.
will not be good enough, and we want to stay on the visible for
Okay.
photovoltaic.
All right. Okay. All right. And what about? I mean, is it just lights that you do, all three of you, or do you do other things as well, like sound or vibrations or anything like that? Do you monitor with? Can you create energy from those?
Yes, so with our power management ICs, power management chips, we can take any type of source.
Okay.
So I would say 80% of the customers and the projects are with light,
Right.
with these partners. But we have other sources like temperature, for instance, heat. Like if you have a temperature delta,
All right. Okay.
you can generate energy, or radio in some very specific cases. You can
Okay.
generate energy
Right.
from radio. There are other examples, but it's the minority of the projects, really.
But from your point of view, you're just receiving energy in from a number of different sources, and it's the IC, it's your power management IC that you're focused on. It's how to make best use of that once you've got it. Is that-
Exactly,
right,
exactly.
okay.
We are taking any type of source,
Yeah.
and then we are really optimizing the end-to-end efficiency of the system
Right.
to, again, avoid losing the energy that we have collected,
Right.
protecting the storage element from overcharge, over-discharge, and also fueling the application in a proper way
Right.
without a voltage decrease, for instance, or stuff like this.
Yeah.
So, yeah, that's what we're doing.
Do you take any kind of energy, or is it just light energy?
We're just solar.
Just solar.
solar,
Okay.
yeah.
All right. So we got, and you're just solar as well. No,
Light.
actually, no, you're just solar. Just light.
Light.
So you're solar energy.
We're outdoor light.
Outdoor only. Okay. All right. Yeah. So the two are quite different. Yeah. So you're going for different applications.
right.
Yeah.
It can be combined. That means we have some applications that are supposed
Right.
to work what we name mixed environment, could be indoor and outdoor.
Yeah.
For outdoor performances, photovoltaic solutions are much more efficient.
Yeah.
They'll be able to deliver much more power. When
Yeah.
it's related to very low luminosity, our technology is supposed to generate more energy.
Yeah.
But something important about the energy harvesting, light is the main one, just because everywhere you have human, you have light. So that's quite easy to even understand before you will deploy your product if you have a chance to get some light.
Right.
Compare when we speak about vibration, temperature, this is generating energy, but not that much, and it
Okay.
could be not as, I would say, relevant sometime.
Okay. All right. Yeah. So more light is more universal
That's it.
when there is light. Yeah.
When there is light. But
Yeah.
again, for indoor application, we speak about deployment or IoT in smart buildings, smart cities, and so on. So we have, even in the houses,
Yeah.
we have light.
Yeah. So just to take that bit about getting energy from different sources, because they're quite interesting. So vibration, for example, would that come from particular types of applications, like, I don't know, from bridges or something like that, or something that gets a lot of vibration, or within a factory, or?
Vibration energy, to be able to collect some meaningful energy, you need a very stable frequency,
Right.
vibration frequency, and to know it. If it's an engine that changes frequency, you will collect almost nothing. So it's very, very specific cases.
Okay.
That, yeah.
sort
Again,
of
most of the projects we have and the energy that we are using is coming from light, either indoor or outdoor.
Right.
And there is no reason to forget about light, right? It's there, light is there, so there's no reason not to use it for
Right.
extending the battery life of the device at least.
Right, yeah. And you were saying that all of your applications are external, outside. Agriculture is the main one?
For LoRaWAN, yes.
Okay.
But I think we're doing buoys on the middle of the ocean. We're doing devices on cattle. We're doing devices on trucks, shipping containers. So a whole range. One thing I think is interesting, and I think maybe for you too, is that most of our energy harvesting devices tend to deal with sort of the concept of efficiency. So they're being used because they're helping people use less fuel, use less water in fields, detect things like fires. I think probably in the building case, a lot of it's about how does the building use less energy. So I think there is, in my mind, the value of all these energy harvesting devices is not to harvest energy, but to do something useful. And I think in a lot of the cases, they're being used to reduce the amount of resources that we're using in our daily lives. So I think it's great.
All right, no, that's great. We're kind of running out of time, but is there anything else that you would like to say?
Yes, I would like to add that energy harvesting also forced everyone in the electronic and semiconductor market to reduce the overall consumption of the product. Because everybody now is really careful and need to be aware about the difficulty to get energy for everyone everywhere. So that drives us to reduce the overall energy needs to power the stuff. So that's really important. Energy harvesting drives us in that direction.
Okay. For a last statement from you, what would you say?
Yes, I would say that it's really mature now and working. It's a reality. I don't see anybody anymore telling me it doesn't work, I don't want it.
Right.
Most of the customers are interested either very short term or slightly longer term.
Right.
So there is no reason not to start. Please come to me with the size of your device and the power consumption, and we'll make it autonomous.
And a last statement for you.
I think the same thing. I mean, this is a mature market. We have lots of products that have been, battle tested really deliberately. So I think the power, that power creation is there. The energy harvesting chips are there. The storage elements are there. So I think there's no reason not to do it.
Okay. All right. Well, thanks very much. I think that's the end of the session. So
Thank you.
great.
Thank you.